Electron current. Electrons in motion make up an electrical current. Current is a measurement of the rate at which a charge flows through some region of space. The term free electron describes a condition in some atoms where the outer electrons are loosely bound. So current is at a rate. A rate is a time. And I think it's described here. The ampere, often shortened to amp, is the unit of electrical current. It's named after Andre Marie Ampere, and also not testable or tested. He's a French mathematician. I think he's dead. And he was a physicist. Amperes are used to express flow rate and electric charge. So the ampere is equivalent to roughly 6.241 times 10 to the 18th charged particles, or I think that means electrons, passing through any point.
Is that considered an actual constant? Or?
That is the volume
Right.
of electrons flowing through any one point.
It's not like Avogadro's number or something, or is it the same?
The term for this is called a coulomb.
A coulomb, right, okay, that's right.
Yes.
This is what you're talking about, it's not the voltage at all, it's
Amps.
Amps, okay.
So and you can think of it like my ping pong ball versus the pickup truck, or a small stream. I can have a stream moving, a garden hose moving at 30 mile an hour, or I can have this massive river moving at 5 mile an hour. You're going to have a heck of a lot more trouble with the 5 mile an hour large mass. So this is mass. This is volume. This is, you're going to move this decimal to the right 18 places. I'd have to it'd take me a minute to write that out, but that's a whole bunch. And that's actual electrons as they pass any particular point per second. You don't need to know the value. I'm not going to test you on the 6.241 times 10 to the 18. So current. 1 amp of current is equal to 1 coulomb of charge passing through a conductor in 1 second. The coulomb of charge equals 6.28 billion electrons. The symbol used to indicate current in formulas or in schematics is the capital letter I. 6.28 billion. That's a bunch per second. So that's where our amp comes from. And I've got a river because this would be a series parallel circuit. This part is series because all the current must flow through these points along here. But then when I get to the parallel, this plus this plus this equals that. And this plus that equals this. Does that make sense? Yeah. However it all spreads out, it all comes back together. So I have a pathway, 2 pathways. So I've got water and current going through both of these paths. And I've got a split here. I could add, as long as I draw a line through anywhere where these three points, if I add these 3, the volume of current is going to add to what's here. I can add these 2 and these 2. I can add these 2, or these 4 together is going to equal this. This one and this one. If I add these 2 volumes or currents, we're going to add up to that. Does that make sense? Anyone having trouble with that?
I think I understand.
It's important to know because we're going to be doing circuits and then we're going to put resistors in here. So you're going to have to realize when I put resistance, and think of it as a campsite, I'll put resistors along here. They're all going to see the same amount of current. Once it gets here, this little campsite here is not going to see the same current here because part of it branched off earlier. So they're going to see less.
Now the amp itself is defined different than current itself, right? They're not the same
Current
thing.
is current would be like, current to amps is like weight to pounds. Current is what I'm looking for and I measure it in amps. So when I ask you a question on the test, it will literally look like this. I total. And your answer will be something amps. Don't get lost on this too much. We're going to do this so many times. There's no sense in even trying to confuse you with the I and the A. This would be like weight and this would be like pounds. So I'm asking for current, but current is given in amps. But I wanted to look at this long enough to at least get, this is something that is really important that you know, and I can draw it separately if it will help. If my water is moving down, whatever passes this point divides up. It's split. These are not necessarily going to be equal. But this pathway and this pathway combined, if I add these together, this right here is my current total because it all passes through here. It doesn't have any choice. Down here, I'm going to have current total. And this path plus this path will combine, the two of them will be current total. You got that? But it's going to split up too. It could split down here and I can have another little offshoot. But this plus this will be total current or wherever it splits. If I draw a line anywhere through here, this point and that point is my total current. If I draw a line through there, that point and that point and that point. Yes?
And is current relative to like voltage drop? So every
Current would be
resist-
more relative to voltage drop is going to be, let me see voltage drop. I don't know how I would give you an analogy for voltage drop.
Wonderful. Wire is longer, more resistance and more drop.
Well, as I add resistance, I'm going to change the current. And then that'll, as a byproduct,
So for every resistor.
voltage is current times resistance. I don't know how to give you a good analogy for voltage. Voltage is going to be the pressure. If I increase voltage, current will increase. So think of voltage as pressure and think of current as water flow. So if I increase voltage, I'm increasing pressure. And if I increase pressure, I'm going to get more current. When you have, where water pressure comes in your house. If you're close to that water tower and it's high up in the air, that's where your water pressure comes from, into your house. There's your house. The taller that tower is, the more weight, the higher water pressure you have. If you're up on a hill back here and you're just barely below the level of that water tower, your water pressure isn't going to be as high. So if I increase pressure, there's more weight. When I open my tap, I'm going to get more current. I get more flow than this guy that's higher than me. Okay, we're going to cover this. I'm going to drill that into you. Let's take a break.
Is there a time limit?
It is.